So one more thing, wall generation, I actually want to change this, and I don't want to be returning a null. I want to be setting up, let's split this up and say if x is lower than 0, or better yet, let's set a target x will start as x, target y will start as y, and if x is lower than 0, then the target x is going to be set as your max x minus 1. Okay, so we're doing a circle. If x is higher than the max x minus 1, then x is going to be set as 0. Similarly, if y is lower than 0, then y is going to be set as, or well, the target y. This also needs to be target x. The target y is going to be set as max y minus 1, and if y is greater than max y minus 1, then target y will be set as 0. Okay, we only move one tile at the one position on each iteration, so I don't have to calculate, differences and all that. So setting that like this, minus x minus y, and what this is going to do is going to take into account, I don't know if I saved, let's save, okay. What this is going to take into account is the tiles that are rounded. So for example, for this tile, it's going to also take a look onto tiles from here. Okay, so you will have an even smoother generation, as you can see. And if it ended with water, then it's also going to start with water. And that is because, we have that is because you can do a circular globe and stuff like that. Okay, so that will be that. Awesome. As you can see, it does look a little bit like cheese, but anyway, we can work with all of this. The next thing we can even try is say that let's try and add some borders. So I'm going to go on to my cellular automata and say if you are actually killing, or maybe if you're creating a count, instead of returning a result, we can return a few more things. For example, let's go and create, and maybe not, let's say we return a node instead of a bool, because a node has, okay, maybe not a node, let's create a node state or node status. And let's delete all of this and just create an enum node state. Okay, and we have water, ground, and grass. Okay, something like this. We'll see how we can change this a little bit later and make it a little bit more dynamic. I guess we can say grass. Okay, anyway, let's go onto the cellular, okay, and change this to node state, which means onto our simulation manager, there is alive should also be a node state, okay, and in the simulation itself, this will also be a node state. So on the cellular inside here, we can say node state, on the result, and it will start as node state dot water. So result will return as node state dot water. Okay, even though we never go in here right now, and result here will be node state dot water, otherwise node state dot ground. Again, ground water. Okay, so let's say that if ground over here, instead of setting this, let's maybe do like this. Instead of setting this to ground, let's set it to grass. Okay, then back to the simulation manager. Whenever we check now for if is alive, we're going to have to do a check. We can still keep the is alive, the bool, and set it to false, or better yet, set it to true, and say if node state, and call the is alive method, pass the node. Let's rename this to alive, to just alive. Okay, and if the state is water, then alive will be false. If not, then set a target color and maybe start from ground, I guess. Okay, change this to target color, and if state equals node state dot grass target color, we now need a new color. Let's call this grass. Okay, to grass. This is some slight changes. We can work with this and change them later. Okay, it's going to hit play. Awesome. Then on the game object, let's assign a grass color, something like that. Let's raise the alpha value and hit play. The first iteration won't have any grass at all. The second iteration, you can see that it starts to have grass, and it's mostly the new cells we are creating. Okay, and you can see that it goes and actually creates like it's grass. Okay, so the similar idea will be to change colors. So if you have any neighboring tile, so let's close that. So if you have any neighboring tile that is water, change this, maybe change it to sand. Okay, let's try one more thing, which is color. Let's say sand, and let's keep the grass, or actually, okay, let's remove the grass entirely, and we wanna do another for loop with the same thing, with another step, but let's call this step public void sun step. Or yeah, okay, this will be a move towards a biome step, but it's not entirely a biome yet. Okay, so we're going to do a new for, actually create base. Okay, let's do all of this, and since we're going to be doing this a lot, we should probably make this a little bit more modular. Okay, so anyway, we're going to check all of this, and we can do this again as a simulation step. So maybe let's do it like that. I'm going to add class find bits cells. Okay, delete this, namespace SA simulation we have the abstract class. Okay, then we're going to have to create this menu name, and let's call this inside simulations, and I'm going to say just bits. Okay, so we have the is alive, and well, maybe we can rename this from is alive to get node state. Okay, let's copy from the cellular automata, because we replaced this, we changed the name. We do need all of this. Well, actually, let's just get all of this. Really? Okay, and it's ground. Copy this. Okay, find bit cells. Okay, over here we have get node from ground, and we're going to have an integer count plus plus count equals 0 actually. Okay, return, let's create a node state for the result. Node state result, node state, let's keep it as ground, and then return the result. Okay, so here's what we're going to be doing. If the node cannot be null anymore, so remove that as well. If it's ground, if it's not ground, we're going to be adding to our count. So if count is higher than 0, then on the result add the node state. Well, on the result node state let's set it to grass. Okay, or better yet, let's just go and do another definition. Let's say, oops, let's keep the grass, but let's change this to sand. Okay, so set this to sand. Awesome. Okay, that's all we need. If we have any node that doesn't have that has water in it, is going to be sand, which means we don't really need to check any other, so we can go and break the loops. And I think, yeah, we can break the loops. Break or okay, so okay, we have our sand, return that. Awesome. So let's go back onto our simulation manager, and before I do this, I'm going to remove these two from here, and I'm going to say do a sand step in here. We have our node grid, but we don't want any of this right now. We only need the node state is alive, so maybe let's close that and let's do a public node state sand, pass the node and copy this current step, get node, and I'm going to change this simulation from current step to set to sand step or bits step, whatever. Okay, yeah, I guess bit step would be better. Bits step. Change that. Node n. Let's rename this to bits. Phrasing is important. Okay, so go from here and in here this will return you a node step, a node state, bits. Okay, so you know what, I think we can let's save alive. Okay, I think we can kind of make this a little bit faster or a little bit more organized, I guess. Anyway, let's do this for now and we'll see if there's any problems with this. We cannot change them later. So if state dot or equals sand, then wall sprite set pixels, set this to sand. Okay, set that color to sand. With that in mind, we don't really need to. No, actually, yeah, the clone grid should work for this as well. So clone grid. Okay, let's do it like this. No, grid is alive and it's ground. Okay, okay, awesome. Close that. Minimize that. Let's go and create our data and our simulations after it compiles, of course, and create simulations for the bits. Find bit cells. Awesome. Let's find something for our sand. Something yellowish. Okay. And hit play. Again, the first time we run this, nothing's going to happen. The second time, yeah, I guess that is a little bit more sand that we need. Okay, so let's go back to our sand, and first of all we need to check if the cell we are setting. Okay, so if the node is not ground, then we don't really need to run this because we know it's going to be water. So return the result over here. You also don't need to assign the count if you're doing that. Okay, so that filters out any already water cells. Hit play. Okay, and now we have edges. Remember that the sand goes on top of the first simulation, so the sand doesn't actually create new world, so it doesn't create new cells, it only listens to those cells. Okay, we have time for one more thing. Actually, let's not do that. Let's leave that for the next part because we are way over time. So, as always, you know what to do. Like, subscribe, and if you like to see more stuff like this, more videos and all these beautiful things, then consider support me on Patreon so we can keep making all of these nice things. I'll see you next time.